Hello again, welcome back to Understanding VXLAN using BGP EVPN. This is video 3. So I want to go over the topology again before I start configuring the spine router. Now, I'm not sure if I mentioned I will not be configuring all these routers here, spine 2, 3, and then VTAP 2, 3, and 4. You're going to see that it's basically going to be the same commands, just different interfaces. There'll be a few different things, but you should be able to catch on just by looking at VTAP 1, and we can look at VTAP 2 and 3 afterwards also. But so here you see that we have 3 VLANs, right? So we have VLAN 10, 20, and 30 for each one. Actually, 30 should be orange, I'm not sure. Yeah, so the orange ones are VLAN 30. And so what we'll be doing here is VTAP 1 will be able to see all of these, and these devices will be able to communicate with each other as if they were on the same switch, because they will be using tunnels to get up to the spine using BGP EVPN to reach the rest of the VTAPs. Here we have the GNS3 topology. I went ahead and removed the configuration from spine 1 and VTAP 1. And I'm going to go ahead and enable the interfaces so I can configure them correctly here. So I'll start configuring. I'll configure it and then stop at the commands that might need explaining. So here we go. Okay, so we are configuring a loopback 0 with the IP of 1.1.1.1. Now, this loopback 0 is going to be a loopback 0 for all the spines, right? And you're also going to have a loopback 0 for all the VTAPs. That loopback 0 is going to be for OSPF and BGP, right? The loopback 1 on the VTAPs will be configured for the EVPN part of the configuration. IP OSPF 1 area 0. Now there are several ways that you can apply or advertise the network in OSPF. You can either do it under the OSPF process with the network command, or you can put it under the interface, and I'm putting it under the interface as you can see here. It just makes it easier. Another thing on that, you can put the IP OSPF 1 area 0 on the interfaces, but if you don't have router OSPF and the ID on the configuration, this is basically for nothing. So you do need the router OSPF in the configuration there. Now what I'm going to do is I'm going to go ahead and configure these 4 interfaces here. Let me start with interface gig 1. Wow. So I do want to show you the interfaces here and the IPs associated to them. Each of the spine is going to have its own network for each interface, of course. And I just wanted to show that to you. Every interface on the spine is going to be a .2, and every interface on the VTEP is going to be a .1. So let's go over the MTU 9216. I want to show you, if I was to do a do show interface gig 2, you're going to see that the default, if I can find the MTU here, is 1500 bytes, right? Now we changed gig 1 so that it would be 9216. Now the reason for this is when you're using VXLAN, it adds an extra 50 bytes. And if you don't change the interface to a higher MTU, then it's going to be overloaded and it will drop the packet. Let me explain that a little bit deeper, right? Because it is crucial. So in a VXLAN environment, the MTU is the difference between a network that works perfectly and one that mysteriously drops traffic. So why do we need 9216 on physical interfaces? So think of the MTU as the size of a shipping box. And let's just say a standard box is 1500 bytes. When the Ubuntu Desktop 1 sends a standard 1500 byte packet, it's already full. So when this sends a packet up here, it's 1500, right? It can't send any more than that. So it gets up to the VTEP, right? So as we discussed, VXLAN is an overlay. When the packet hits VTEP 1, the switch takes that 1500 byte packet and wraps it inside a VXLAN header, a UDP header, and a new IP header. This wrapping adds extra 50 bytes of extra cardboard to the package. The package is now 1550 bytes. If the physical interfaces on the spine and the VTEPs are still set to the standard 1500 bytes, they will look at this 1550 byte and say, this box is too big for my shelf, throw it away. So it's going to drop it. So by setting the MTU to 9216, which is often called jumbo frames, on interfaces like 1/1 and gig 1, and here's your 1/1 and here's your gig 1, right? You're making the pipes much wider than the packets. This ensures there is plenty of room for the original data plus the VXLAN headers to pass through the underlay without dropping. Now you may ask, well, okay, but we have a loopback in here. Show run interface loopback 0. Why isn't it needed here? Well, this is a virtual IP. This is not a physical IP. So really, packets are not going to be going to loopback 1, or I'm sorry, loopback 0. Now let's talk about the next command under interface gig 1, which would be the IP OSPF network point-to-point. Okay, so by typing that, the IP OSPF network point-to-point, you're basically giving the spine a specific set of instructions. It tells the spine there's only one neighbor at the other end of this wire. Don't bother holding an election for a leader. Because it skips a 40-second wait and see period for the election, the OSPF adjacency forms almost instantly. And again, here you have the IP OSPF1 area 0, basically advertising this network under OSPF. So here you can fast forward. I'm going to go ahead and configure gig 2, 3, and 4. So let's go ahead and configure OSPF, router OSPF1. We're going to give it a router ID. Same as the loopback. We're going on 10 minutes here, so I'm going to go ahead and stop the video. In the next video, we'll go ahead and configure BGP and L2 VPN, EVPN. I'll try to explain those commands in less than 10 minutes. I will see you there.